Alright guys, welcome to another edition of the fun-filled, action-packed geometry flip classroom video with Coach Gru. And today, on today's episode, we're gonna go over properties of equality. So we're gonna learn a bunch of rules that you're gonna start using all over the place. So let's get it started. I'm actually gonna give you one of these, and then I want you guys to try to figure out some of these rules yourself. You can always check obviously after you try them out, but we're gonna do one. I'm gonna show you the addition property of equality, and I want you guys to try some of them. So here we go. Addition property of equality. First of all, in all these first if blanks, I want you to go ahead and write if A equals B. Just in all these blanks, if A equals B, if A equals B, if A equals B, and then we're gonna add it. We're gonna throw in a C. So if A equals B, then for the addition property, it's gonna be if A equals B, then A plus C equals A, B plus C, just like that. That's the addition property of equality. So what do you guys think would be the subtraction property, the multiplication property, and the division property of equality? I want you guys to try to figure out those properties of equality on your own, and then you can check back. I'm gonna give you, pause the video right here, and then when you come back, you're gonna see the answers. Alright guys, so now you've unpaused the video, and here are the rest of the properties for subtraction, multiplication, and division. So if A equals B, then for the subtraction, it's gonna be A minus C equals B minus C. For the multiplication property of equality, if A equals B, then A times C equals B times C. And finally, for the division property of equality, if A equals B, then A divided by C equals B divided by C. Okay, so now moving on. Distributive property. Let me scroll down a little bit. Here we go. So we're gonna hit the rest of these ones. Okay, so let's check these ones out. The distributive property. If A times B plus C, then A times B plus C equals, you guys should know this. What would we do here? We would distribute. So just like this, boom, boom, and we would have then A times B plus C equals AB plus AC. That is all the distributive property says. A lot of these rules you've been doing without actually knowing, this actual property of equality. You just kind of do it because we've learned it, but these are the actual properties that allow you to do such things. Now, next one, substitution property. If A equals B, then A may be replaced by B in any expression or equation. You already know this. So for example, if A equals 10, say B is 10, then instead of writing A in an equation like A plus 5 equals 10, you would just write 10 plus 5 equals 10. That's pretty much what this one's saying. You just substitute. And now for the reflexive property. Now this may seem a little, obvious to you, but there's actually a rule for this for any real number A. So if A is a real number, then A equals A. Believe it or not, that is true. For any real number A, then A equals itself. It's a little bit crazy, but believe me, it's true. Next one, the symmetric property. If A equals B, we always kick it off with the A equals B. Then think about symmetry. What does symmetry mean? When you look in the mirror, it looks back at you and it's the same. So if A equals B, then B equals A. We switch the order, but it's still the exact same thing. And now for the very last one, the transitive property. If A equals B and B equals C, then A equals C, right? So if I told you, okay, this is not actually true, but if I told you a cat is really a dog, but a dog is really a giraffe, then technically, through the transitive property, a cat is actually a giraffe. You get it? All right, anyways, moving on here. So now we have finished learning all the rules, okay? So we're going to go over something crazy now. Using the properties of equalities. Why did we just go over these? So we can use them, because now we're going to use these properties of equalities to justify steps in solving an equation. So we're going to learn how to do a 2-column proof, y'all. All right, so here we go. 2-column proof, a common format used to organize a proof. So it's going to be 2 columns. You can get a sneak peek right here. And on the left side, you're going to list the statements or steps. And on the right side, you're going to list the reasons that justify each step. So how did you go from one step to the next? And what can you use as reasons? You can use theorems. You can use postulates. You can use properties, like we've just learned. And you can use definitions. So now this is where this, you know how we've been telling you guys, go step by step, show your work when we're doing these problems. Some of you guys, you're like, no, I'm not showing my work, I'm going straight to the answer. Well, guys, if you don't show your work now, you're not going to be able to do this, because these problems you have to go step by step and tell using theorems, postulates, properties, and definitions how you went from each step to each step. So follow along here. I'm going to go over a couple with you, starting with number 1. So first, your first line is always exactly what they gave you. 4x minus 1 equals 27. How do I know this step is true? Well, it's given. It's given. That means they gave it to me. Look, given. It's written right here. Given. They gave that one to me. So we started off with that. Okay, now what would we normally do right here? We went from this step, 4x minus 1 equals 27, to the next step, 4x equals 28. How did we get from one step to the next? Let me get this stuff out of the way. Well, from the first step, we would add a 1 to both sides, plus 1 plus 1, and that would take us to 4x equals 28. Now, how did I get there? What property did I use? Take a look at your properties. Which one has anything to do with addition? The addition property of equality. So I can just write add prop of equality. Unless you want to write the whole thing, you can, but I'm just abbreviating. Look, addition property of equality. Okay, next step. How would we get the x by itself? Because look, remember the goal is written right here. I should have told you at the beginning. That's my bad. But the goal is written right here. They're telling you what they want you to prove. They want you to prove that x equals 7. So they gave you the answer. The prove is always going to go in the last slot right there. Boom. X equals 7. So how are we going to go from 4x equals 28 to x equals 7? Well, we would divide both sides by 4. Okay, and that would take us to x equals 7. Boom. But how did I get there? Which property has to do with division? The division property of equality. And there it is, guys. We have done our first algebraic proof, our mathematical proof. Oh my goodness. It's like you're using your brain to tell me how I'm going from step to step. That's crazy. Let's do a couple more of these, guys, before I send you on your own and you fly off out of your cocoons into beautiful. Okay, anyways, screen sketch. Here we go. Now look at this one. It looks a little more complicated. Number 2, we're given that a over negative 6 plus 2 equals 5, and they want you to prove that a equals negative 18. So once again, look, our proof has been stuck in the last spots, okay? Now, the first line, remember, it's the given. Straight into the first line. And what's the reason? It's given. They gave it to us. Now, let's go step by step. So what would we do first? First, we're going to subtract 2 from both sides. And that would take us to, boom, a over negative 6 equals 3. But what property did we use right there? We used the subtraction property of equality. Sub prop equal sign. Subtraction property of equality. Okay? Man, when I was in high school, we had to write the whole thing out. Our teacher takes points off. But look at this. We'll let you guys do a little abbreviating. All right, next one. Now we got to go from step 2 to step 3. How did I go? What are we going to do next? We're going to multiply both sides by -6 times -6 times -6. The x is that's a multiplication x, not a variable x. Okay, multiply by -6 on both sides. Boom. That would give us a on the left side and -18 on the right side. And what property did we use there? We used the multiplication property of equality. The multiplication property of equality. So how do I get from this step to this step? How did I get from 2 to 3? Every single step you're telling me which property you used. And now we're going to do one more together before you guys try the rest. So number 3. Oh, this one says you try, but I'm going to do it with you guys anyways. Look at me. All right, so this time they give you that -9 times 2x minus 3 equals 63. And we're going to prove that x equals -2. So once again, the proof looks straight to the last spot. Boom. The given straight to the first spot. And the reason is that it's given. So let me get rid of that. We don't need to see that because that's just getting in the way. So let's go step by step. First, we have a -9 outside of the parentheses. And look, they got it to -18x plus 27. How did we do that? We distributed. That's all we did. What property did we use? Isn't there one about distributing? Yes, there is. It's literally just called the distributive property. Wow, that's crazy. Distributive property. We distributed and we used the distributive property. Okay? And now next step, how do we go from 2 to 3? We subtract 27 from both sides. Subtract. And we are left with -18x equals 36. Which property did we use in that step? We subtracted 27. So we use the subprop equal sign. The subtraction property of equality. And our final step, how do we go from 3 to 4? How do we prove this? We divide by -18 on both sides. And that gave us x equals -2. And we divided by -18 on both sides. So we used the division property of equality. And there we have it, guys. So this is a mathematical proof. They will get more complicated, but always think step by step. Then look at your properties, look at your rules that you can use to prove it and get to that last step, guys. All right, so you guys try number 4 and number 5, and then we will check the answers once you get into class. That's the end of this video, guys. I'll see you in the next one. Peace.